They're
You should
always,
have that pop-up there.
yes.
Great.
There are always all sorts of gremlins in the system, and this is going to be potentially fairly interactive. It can be as we need it to be. If people want to ask questions, put your hands up, and I'm happy to stop, and we can go through that. Right, I'm going to start by showing some slides, and then I'm going to sort of dip in and out of different bits as we go through. And if you want me to stop, just shout. So, right, okay, so my name is Matt Stammers. So, as Vanessa said, I'm a doctor in the NHS. And probably some of you are wondering why a gastroenterologist is talking about system dynamics modeling, which is a slightly odd thing to happen. I'm a slightly unusual gastroenterologist. I started programming about 7 years ago and got very into particularly Python and open source software development. And then during COVID, I started getting involved in system dynamics after I met Peter Lacey and the whole systems partnership guys. And that's where RUM came from. And I've spent basically my whole career up to this point facing the obstacles that we all face in the NHS, security barriers, sharing barriers, all these difficulties which often make it hard for us to share our work and disseminate what we're doing. And hopefully in this talk, I'll be able to take down some of those barriers. I'm not going to be able to take them all down, but we can start to take them down. So, right, so basically this is RUM. So the idea of RUM, so myself and Peter, who's on this call, as well as Mark, and Abraham, started RUM in January of this year. And the vision of RUM is basically to disrupt the current proprietary lock-in which currently exists in system dynamics. And basically, the purpose of doing that is to free system dynamics within institutions like the NHS, such that it can scale, people can share models, and we can hopefully transform the way we deliver modeling in the NHS, and also reduce the cost of it as well in the process, making it more available for a wider, more diverse audience. So these are the kind of proprietary platforms that I'm sure many of you know. So probably the two most popular are IC, Stellar Software, and Benson. And then there's Silico and AnyLogic, and there are about 10 others. And they have lots of good points. So they all have very powerful backend engines. They're all built bespoke to solve system dynamics problems for users. They have a nice GUI interface, so they're easy to interact with. And therefore, it makes onboarding people easier. It makes it easier to build models. They're kind of friendly. As long as you're in the same ecosystem as other people using the same software, it's very easy to transfer those models. And everything is fantastic as long as you're in that ecosystem. The problem is that switching ecosystems is a high-cost process. Most of these technologies cost thousands of pounds a year, sometimes even for just a single license. And that makes it very difficult to share models outside of your sort of home system. And it makes everything non-interruptible. It means that clients can't sort of change models. People you're working with can't see what you're doing. And therefore, you can't combine it with other technologies. And it becomes very stultified and difficult for others to access. So these are the big problems. And this creates, significant barriers to newcomers coming in. And a generally sort of non-collaborative environment with lots of walled gardens, which creates fairly small scale thinking in terms of solving problems. And this is something that we're hopefully starting to address today in this conference. So what do we do about this? We could just accept it and accept that we have these barriers and we can't easily overcome them, or we can try and find a solution. And the solution that's been found in other sectors is open source, which I certainly believe is the best option to overcome this here. So open source, just for those who are sort of not very familiar with the term, just means that the source code for the software is completely freely available. So it means that anyone coming in can see exactly how the application runs, they can fork that code, and they can create their own bespoke solution. And this fosters hybridized thinking, collaboration, and generally it fosters the best kind of development environment that you could have, whereas closed source systems tend to become somewhat stagnant over time, and tend not to develop in the same way. And we've seen this in many other sectors. So some good examples of open source development are Linux, which runs most of the servers in the world. Apache is a massive software foundation that developed all sorts of technology, which underpins almost all commercial companies in the world will use some kind of Apache software underneath something that they're running. And then you've got TensorFlow, which was developed by the Google Brain team, and which has become a very, very successful system for showing machine learning models. And as a result, these areas have grown. They've got your mass adoption, and you make big progress. But in order to have a standard, in order to have something that you can build upon, you need an agreed upon, recognized universal standard for interoperability. And in that case, in the case of system dynamics, that is XMILE, which is a bit of a mouthful. I'm just going to post the link to the documentation for XMILE in the chat, so people can have a look at this if they want to. Basically, these are the international standards which have been proposed, which every single software model working on system dynamics should compile to. So the idea is that this provides a common framework from which we can build. And if I just switch views a second, so let me just show you this. So this is some XMILE. So if any of you have seen XML, XML is basically an interoperable data format. It's kind of ugly. To be honest, it looks quite difficult to read. It's not particularly human readable, but it can be read, and it allows you to lay your code out in a way that makes sense. So you can see that this one is a XMILE file compiled from, in this case, Stella, running version 2, and then we've got all the different objects in that model within this file. It's not something you'd want to spend a long time reading, but it is interoperable, and that's the foundation for anything that we then try to build upon. And feel free to read that more about that. The last standards came out in 2015, so it hasn't changed in 7 years, which is a good and bad thing, and it means that it's stable, and that's what it looks like. Okay, but this alone is not going to help us. No, so we can't just read these files. And as you know from using Stella, Vensim, and other softwares, it gives you a graphical way to look at software, which is look at the models, which enables you to understand them. And now humans can't look at this and understand this. So what we need is what's called a framework. So a framework is basically a set of code, a code base, which allows you to take the interoperable standard, in this case XMILE, and then use that standard in a way that's interoperable, so it can be shared, that save time, and also hopefully increase quality. So a good framework will do those 3 things. And in SD, we have currently about 5 or 6 different options. So these are the currently available ones. The premier open source framework, if you like, is called PySD. I'll just stick all these in the chat so people have got them, so that they don't need to sort of copy it from the presentation. I need to get it off. Yeah. So basically, all these frameworks are free. They can be used by anyone. No, you don't need to pay for them. So this is why they're very attractive for the NHS, because it's not something that we have to pay for. In fact, I can't get them off. I'll put them on in a bit. But basically, there are 5. So PySD is the most popular one, the most successful. And then we've got SDMR, which is by Jim Duggan. We've got BPTK, which was developed by Transcentis, which is a German SD company. We've got DSolve, which is not really a framework for system dynamics, but it's a package for doing differential equations from which you can build SD models. And then we've got ASDM, which is the one that we are working on. And this is, if we were to put them in a table, there are others. There are going to be others that I am not aware of, and people should add to them. But these are the kind of best, easiest ones to find, with the exception of ASDM, which is new. If you put them in a table, you can compare them. And the best way of comparing frameworks is by the number of stars that you get. So the number of people said, this is good, I know this works. And in this case, PySD is ahead. So it has 256 stars. And then it has an accessible tutorial. We talked already about documentation. The documentation for PySD is very good. It has what's called an XMILE compiler, which means that you don't need to build the model individually piece by piece. You can just compile it from an XMILE file, and it's very easy to compile. So PySD is definitely the premier framework available currently. But there are some others. So there's Jim Duggan's framework, which is basically SDMR and then PySD2R, which is a PySD translator. He's written a book which goes through it all. It's a bit more difficult, a bit more technically difficult to get your teeth into it, but it works. And if you're into R, then that's a very good option. Alternatively, you've got DSolve, which allows you to do differential equations, which is obviously gives you a lot of flexibility, but it doesn't allow you to compile these XMILE files directly, and it's quite hard work. So you've got to have pretty good mathematical understanding. And then we've got ASDM, which we'll talk about. I'll talk about a bit at the end, which is we're still in development. It's not in production yet, but what we're trying to do is solve some of the problems that these other frameworks have. Okay, so I guess the next part of this is, again, something that's come up already today, is what is a really useful model? So it's great that we can build these fantastic models, but if they're not useful, so if we can't pick them up as analysts or business intelligence leaders or operational leads, then they're no use, and then we may as well not build them. So we need to define that, and we in RUM see really useful models as being problems that lend themselves to ST. So not every problem lends itself to ST, and if you need something which can be solved by ST, then it's worth doing. And then you need to have clear inputs. If you don't know what the inputs are, you can't build a model. It needs to be something that's easily sort of replicatable, distributable, and modifiable, for it to be really useful. And then the data needs to be accessible, so you have to be able to get hold of it and applicable to the real world. So you could build these beautiful models, but they may not have a real world application, and that's the final kind of piece of the puzzle. So now what I'm going to do is I'm going to go through a few examples, and we can go through them as quickly or as slowly as you want to. It doesn't really matter to me. And if you want to ask questions, then just put your hands up in the chat. I'm just going to put that there so I can see it.
There is a hand raised now.
Yes, yes, let's do it.
Take that question now.
Yes, yep.
Yeah, sorry to interrupt you.
Okay.
Yeah, I'm very new to dynamic modeling, so my question is pretty naive. I attended a training on dynamic modeling the week before, and they be asked to install a software called Stellar.
Yes.
And now you're talking something about the framework. I don't know what's the difference between these two things. For Stellar, my understanding, it can be completely wrong, is they need the number, the data into the software, and then software will build the model for us. Is this a framework? It's kind of something like a machine learning, this kind of thing. You use the code and build the model yourself rather than use a pre-installed software.
I think I know what you mean. I think it's probably easiest if I show you. So this is Stellar here. So this is Stellar. Have you installed it yet? And so Stellar doesn't build you models per se. There are recipes coming and things like that. So Stellar is I would describe it as a very beautifully designed way of building models. It's very intuitive. So if you want to add a stock or a flow, you can just basically ping one there and call it stock one. It's very easy to use, and this is what we're talking about when we're talking about a proprietary platform. So this is a company called IC Systems, and they own this product, which is Stellar Architect in this case, and they sell this to other institutions such as the NHS. So it's kind of a full suite to develop your own models in. That's basically what Stellar is. What I'm talking about is basically trying to avoid needing this product. So when I'm talking about frameworks, so if I literally go into Google, and if I look for, because I'm presenting, it's playing a bit funny, but if I go here and if I look for PySD, so PySD as an example is a framework. So if I click on this, it will take me to the PySD documentation. So this is completely free. So nobody owns this. No, you can do what you like with it. It's completely free, and you can use this to create models like you can here. So that's basically the difference. This one you have to pay for. This one is free. I saw someone else's hand go up, so we should. Why don't we do that and then see? It may be connected to this. Did that make sense, Chenyu? I know.
Yeah, it makes perfect sense. Thank you so much. Yeah,
Right,
I understand now. Thank you.
How's it going? You're right.
Is it that
So
one?
PySD is Python to run, right?
It's Python. Yeah, it's a Python framework. Yeah.
Right.
So what it does is it takes XMILE and then it compiles it into a format which you could run in Python. Yeah.
So I'm not techie at all. I work in a QI team. So as far as kind of getting a model up and running using PySD, is it literally just clicking that link to the and then downloading Python, clicking that link, and then will it run, or do you have to do coding?
There are a few setup steps. The beauty of what I'm showing you here is it's really clearly documented. So if you click on this getting started button, or in fact, before we do that installation, it tells you how to install this, from the start, basically.
Right.
And then the getting started goes for a tutorial, which explains kind of how it's used. There is more of a learning curve to this than there is to Stellar, and that's the downside of these frameworks. But you don't have to pay for it. That's the
which is key, because we haven't got any money.
Yes. Someone else has put their hands up.
Elizabeth.
Hi, yes, just a very quick question. Let me put my camera up. It's about the installations of these applications, because we are very restricted in the NHS about what do we install in our services.
Yes.
So how do we overcome that issue? Because probably we have to write a business case in this organization to get the approval from IT to install any of these services. Is there any way that we can overcome that? Thank you.
That's a really good point. And this is a massive problem in NHS organisations, because NHS organisations tend to be a little bit on the paranoid side, and therefore tend to lock down all of the access to local terminals and stop people from being able to be sort of local administrator and things like that. My experience has been, as long as you build relationships with people in the IT team and you explain what you're doing in a way they can understand, they will give you permission to do what you need to do. The difficult bit, as you say, is preparing that business case or making that case clear. We've had various problems here where, for instance, someone's muted me. Should we go to no? It's a difficult problem, and but if you work with your IT team, it should be overcomeable.
Yeah, I just wanted to mention, Matt, my experience, because it was difficult for us in NHS England as well. So what we have done, and we are happy to share that resource, we have done all the comparison of softwares. If people need to make the case, and then you have to raise it with your IT teams, we are happy to provide you information that we already collected, because we went through that process of showing why we need this. Why IT, in my case, IT took only 1 year to allow me to install that. It took actually the IT colleague 2 minutes, but for me to get that sign off to be able to install a commercial package took only 1 year. So the support was already expired by the time I managed to get it in my machine. So there is some resource available if someone needed.
Yeah, Andrew's got his hand up as well.
Yeah, I was just going to say, depending on what links you've got and what job role you've got, is work with your BI team and go as a group rather than an individual, and then let the leads, or if you're the lead, is then get everybody on side in that sense to sell what it is supposed to do in the outcome. Similar to a business case, but I'd get those probably a little bit closer to the IT team to sell that idea to them. But I do understand there are restrictions, and there are for us, so we have to do the same, even as analysts. I just wanted to add that.
Yeah, fully agree, Andrew. And it's about building that trust. That can take time, but by using what Vanessa's proposed and basically going with the blessing of centralized kind of NHS authority, that would really help. And I think once you start that journey, it opens the door for everyone else as well. Peter?
Just have the advantage of knowing where you're going with this, Matt, because we've shared the presentation, and I'm just going to sort of comment to others that open source is great in terms of it being free, but it does require quite a decent level of analytical capability that's well beyond mine. Douglas has put a comment in the thing, is it possible to build a one-stock inflow and outflow model using PySD? Well, yes, but it won't look as tidy as building it in Stellar. And this is a long-term goal. Sort of disrupting the market like this doesn't happen overnight. And indeed, what we'd be saying, I think what Matt will come to, is that there's still sort of options. But if we're going to be really serious about spreading adoption and building the analytical capability and using things like PySD and other tools, then we've got to break out at some point. So it's just a sort of, this is the direction of travel. And I'm really, really pleased by the sort of comments, because it indicates the readiness of the health and care sector to make this sort of step. And it's very early days, infant steps, I think, required, but Matt's a great proponent of the direction of travel.
Yeah, someone's just put in there about the cybersecurity team basically not wanting to let them have anything on their computer. That is, the cybersecurity team are probably not the best people to go to first. I would argue I'd start with the BI team and go via the BI and sort of IT teams, because they will probably have more understanding of what you're trying to do, and then get them to help you with the cybersecurity team, because the cybersecurity team's job is to basically say no. So once you can get past that, you're much more likely to get through. Jennifer?
I'm really sorry, I'm jumping in right at the end here, but from a Wales perspective, we have this issue, and we've got even more of an issue now that we're moving to Office 365, because a lot of the open source softwares have files that Office 365 doesn't like, and IT put things in the wrong place. So what I was just going to suggest is this is something potentially for community of practice to have a document that people can go to IT with, because even in Wales we've got 7/9 different organisations, all with their own IT teams, who all implement and install things in different places. So if we can kind of get over that hurdle. And the other one I just wanted to mention is that if you as an analyst are having trouble getting the software installed, what about the customer for your work? So let's be clear about how they will then access the tool as well. So it might need a slightly different solution. Sorry if that's been brought up already and I'm just jumping in.
This is all really important stuff, and there's no point discussing doing this if you can't install it on your machine. And it took me probably about a year as well to earn IT's trust in this trust. And it started with them saying, yeah, okay, we have buy-in now, crack on. It's hard, but I think once you've started that journey, it gets a lot easier. Once they know you're not going to wreck everything and act in a rogue way. Shall I share this, and we can come back to, I can do a demonstration, we can do whatever we need to do, but I think it'd be useful to share kind of some examples of doing this. So the first scenario here is basically this. You imagine you're working in ICS, and they want to start up a new smoking cessation program. You can put in here whatever you like. It could be any kind of a vaccination program, whatever it's going to be. And they want to know how much of the savings they make from the program and how much of that should be reinvested to obtain an optimal result. So this big problem can be solved with a fairly simple model. So this is what the model would look like in Stellar. So I will just switch to Stellar so you can see it. So basically, this is Stellar here. I can delete the stock because it's not doing anything. So this is the model here. We've got 3 stocks, we've got 2 flows, and then we've got a few auxiliaries. And if we run it, and as is, this is a training model. It's not meant to be sort of production ready, but you could tweak these variables to make it into something useful. You can see that effectively, if you set the percentage of smoking cessation at 80%, you get pretty good smoking reduction. If you then decrease it to say 50% and you rerun it, you get a much less impressive level of smoking reduction. You've still got quite a few smokers left at the end. And you can do this in Stella very easily. I know it doesn't take very long. If you're experienced with it, you could probably build this model in about 5 minutes in Stella. That's the power of these kind of things. But you can't share this easily with someone else. I mean, you can get them to download Stella, I think it's called Stella Player, and get them to run it in Stella Player, but they couldn't really change the model, and they wouldn't be able to easily, it's not one-click play, no. And so what I basically did with this model was I thought, well, how do I make this work? So I got, let me open the folder up. So basically, here's the smoking cessation model. So this is the training model here. So we've got our image here as it was. And then I thought, well, I'll play around with all these frameworks and make it work. So you can make this work in PySD. So PySD will make a nice, beautiful file, .py file, which you can run. You can run it in any of the frameworks, it will work. But the nicest way of doing it for illustration purposes is using ASDM, because it lays it out in a way that's very clear. So what it does is it creates, this is the model. So in Python, you have these things called objects. So here's the model, we have the object, we have the, and then underneath that we have the stocks, the flows, and the auxiliaries. This is identical, I can't see my my Stella now, to this. They're no different, it's just in a Pythonic format rather than in a Stella format. So, oops, sorry, I've got so many different ideas. So let me go back to presentation. So if we, so this is the same. These are identical. And there's no difference between them. It's just one is in text format. And what this allows us to do is once we've got the model in a Python format, we can then deploy it online. And so to do this, I've used Streamlit. You can use Shiny. You can use any open source framework to display it. And if you go to this URL, you can see it and you can play with it. So let me just get the URL. I'll post it in the chat so people can just click on it. And this is the beauty of this is that you can just click on this and it'll work. So if anyone, it might overload the, I don't know how many people are on this call. It's about 60 people. If all 6 people run it at once, it might stop working. But it's not difficult to deploy these things.
You're still showing the. Were you intending to show the? Online. You were still on the slide.
Let me just do this. Okay. Okay. So let me share this. So can you see this now?
Yeah.
So this is, if you click that link, this should work. So someone's asked an interesting question, which I'll come to. So this is exactly the same model. It's exactly the same as it is in Stella. So it's the same here. But instead of tweaking this number and rerunning it, in this version, all I need to do is move the slider. So basically, say I want to reinvest, and basically what you can do is you can develop the model. You can then send the URL to whoever the stakeholder is, whoever the client is, you want them want to play with it, and then say, look, this is the model. You choose how much you want to reinvest, and the model will tell you what will happen. So in this case, go on. Did someone have another question? Just to sort of elucidate how this works. So basically, if you set the reinvestment at 60% of the savings, then you get, in this case, 200 people are still smoking at the end of 36 months. You will still get more lapsed smokers, but you manage to get quite a lot of people that stay ex-smokers. And it's very simple. It's a very simple illustration. And these frameworks work very well for simple models. Someone has just said about, do you create the model in Python or do you need to write the code yourself? And the answer is you don't need to write the code yourself if you have the model from Stella. So when you go in Stella here, if you save the model as a STMX file, that is the same as a XMILE file, which looks like this. And then if you compile this using PySD, that would be where I would probably start, you get a nice .py file, which allows you to run the model very, very easily. Let's see if I can see it. So somewhere in here, I can't find it. But it's very simple. I know it's very, very easy. And you have to play with it to see how simple it is. But what I'll do is I'll keep going through the examples, and then at the end, if you want me to go through one, bit by bit, we can, or we can just talk about it. Okay, so the next example. So I will go to this one. So Aaron just asked about you need to access Stella, not necessarily. So if we go to a lot of jumping around here, unfortunately. So if we go here, so this model here, which I've created in ASDM, this does not involve Stella at all. So there is a couple of imports here. We've got the picture just to give us an illustration of how the model should look. This is just written out by hand. No, so I've just said I want this stock, I want these ex-smokers, I want these lapsed smokers. I don't want any of them to be negative. I want the flows to go from current smokers to ex-smokers, and from ex-smokers to lapsed smokers, and I want these auxiliaries, and then I've added the equations which are in the auxiliaries to this model. I know, so this doesn't involve using any proprietary platform. The problem with this, as I'm sure all of you are aware, is it's more difficult because you've got to conceptualize the model in your head. And that's one of the problems with the open source frameworks at the moment, which is something that we plan to solve. We're not there yet. Okay, let me go back to presentation. So there will be a bit of sort of jumping around because there's lots of different bits to share. And if you want to see the source code, just go to the GitHub repo. So if you go to the really useful models one, or my one, you'll find all the models. And I'll just put this in the chat as well so people can get to it. Okay. And yeah, if any other questions, just ask them. So, okay. I'll come back to some other questions. Oh yeah, should we do the questions that are there?
Up to you, really, Matt.
So they just said about, do you need to understand how to write code or proprietary software? So the answer to that is not necessarily, because if you want to run a PySD model, I'll show you PySD. It's very, very simple. So all you need, so this is a PySD model here. The only thing you need is to import PySD. You don't need to be able to code in Python. You just import. No, there's no problem there. So that problem because it doesn't exist. You need to import PySD. Then you run the read xmile command on the xmile file of the model you already have, and it will compile it for you. So you don't really need to be able to code. And then you've got your model, and from the model, I'm then running it and adding this variable, which is the slider that you saw, and then exporting it to Streamlit. And that is how simple this is. So, but yes, you need to understand a little bit about Python code to do it, but it's not difficult. And if you follow the PySD documentation, which is really clear, you will be able to get through the process, bit by bit. What was the file format from Stella, and does it import in the port to PySD work from other paid software? The answer is yes, it will. So it doesn't matter if it's a Vensim, if it's AnyLogic, they all export to xmile. And once you've got the xmile format, you can read them using PySD. So, but you do need the model to be able to compile them. That's the caveat. So this bit is right. So Jimmy is right. If you don't have the original model and you don't have the software and you want to create the model, then you would need to be able to code. Yes, that's correct. And that, at the moment, but that is changing. Yes, and as Sally said, in fact, I didn't know about this one, insightmaker.com. So this is what's needed, is basically non-proprietary platforms which enable you to build the models, and then you can spin them out. Look at this, looks good. So this potentially could be very good. Yep.
Just about Insight Maker, I have met a couple of people who have used it, and they mention about confidentiality is the model are not host in your machine, they are somewhere else.
Yes.
So if you are modeling something that in which you're using national available data, is fine. But then if you're using something that you want to keep close to yourself, then Insight Maker will present some issues at some point.
And that's the same with Streamlit. In Streamlit Cloud. So I've deployed this to Streamlit Cloud. It's not confidential at all. It's just it's a model, that's completely free open source. It doesn't matter. but you do have to be careful if you're trying to deploy it in something that's potentially sensitive, in which case you need to deploy it inside your own network, or using Power BI or Tableau or another analytics platform which you have set up locally. So I'm only using Streamlit because it's very simple to set up and easy to share. Can it go the other way? Yes, it does go the other way. Yes, the whole point of XMLE is you can go both ways. Okay, let's do. I'll have a look at Insight Maker later on because it looks quite good. Okay, so let's do the second scenario. So I was given. So basically, my colleague was sitting next to me a couple of weeks ago, and she said, "I've been asked to work out how long it's going to take us to get rid of the 78 weeks waiters in the trust." And I said, "Oh, that's something that will work for using SD." And I was like, "Okay, well, let me just make you a little model." So I sat down and I made a little goal gap model. And basically to try and help her to work this out, because there wasn't any tool in the trust to do it. So if I go back to Stella, I will show you what the goal gap model looks like. So this is a goal gap model. So it's really simple, this one, which is why it's so beautiful. So you have only two stocks. In fact, you can just have one. So you have the number of people waiting is the first stock. And then you have the goal, which in this case is 0. So you want to get rid of the backlog to nothing. And then you have the gap, which is calculated by the difference between these two. And then you have the adjustment period, which is how long it's going to take to adjust. And then you can run the model like this and get the answer in Stella. Easy. But I can't deploy this to her without giving her Stella, or using Stella Player. So I was like, right, I'll make a little app for it. So I went on, I compiled this in Stella to make it quick, but I could have used ASDM as well, which I'll show you in a minute. And then I deployed it here. So this is the one. So let me just get this and post the link in the chat. So this model is really simple. So this is where I would start. So this one here, and the source code for this is here. So this model is online here. Let me just make sure you can see it. I'll just open it in the browser in here, and then you'll be able to see it. So if I just go here, so I'm working on 2 different machines as well, which makes it extra confusing. Probably everyone's trying to get into it now, so it will sort of struggle a bit to load. See if it will load. So I'm just loading it up. Ta-da! In a minute. So this is free hosting, so I didn't pay for this, so it may not scale up in the way that you would want to use it if you're using it in production. But it's completely free, and it allows you to share models for free with anyone around the world once you've compiled them. And it's taking a while to load, so I'm just going to switch it into here quickly. Okay, so this is the model. So it's this one here. Once you click off them, they only cache for a certain amount of time. Here we go. So this is actually our trust backlog. So our trust backlog is 3,253 patients waiting 78 weeks, which is why the ISS are not very happy. And they want to know how long it's going to take for us to clear that. So what I did was made this, and I said, look, just play with this and work out what you want. Look at what happened last time and how long it took. And what she found out was that it took about 3 months last time to clear half the backlog. So therefore, it's a reasonable assumption that it will take about 12 months to clear the majority of the backlog. And this is obviously, in consultation with the COO and the people who care about this. But this is a very reasonable assumption to make in a very simple SE model, and that works quite well. And it's easy to deploy. And if you want to, you can fork this code. You can do whatever you like with it. So if you go to this website, if you go to the goal gap model website, all you have to do is set up your own GitHub repo, and then you just click fork here, which is this button here, and you can just do what you want, or you can just download it and change it. The whole point is it's completely free. People can do what they like. Okay, let's go back to the next bit. So let's go back to presentation. So any questions about that one? No. Okay, we'll go on to the next one because we'll go on to a bit more complicated one. So, and if you want, I can go through how to go through each step, but we may not have time. Okay, the problem, and this is where the rubber hits the road, and why not everyone is using these frameworks only all the time, is that sometimes you can't compile models. So once they get beyond a certain amount of complexity, you will struggle to compile them. And the one I'm going to show you next will not compile in PySD or BPTK. 2 is the issue of non-visual editing. So we talked about that. So you have to generally code them out unless you can find an open source designer tool, which is one of the missing components for the frameworks at the moment. And then the other bit is the technical learning threshold, which is you do need to know a little bit about code. You don't need to be particularly sort of an expert or anything like that, but you do just a little bit to be able to use it. So these are the drawbacks. This one's always going to be there to some degree, but these two can be overcome. Okay, so the next one is the elective recovery model. So Peter presented this earlier on. So this is a sort of demo model, a more complex SD model, which is actually used in production in other places. And the question here is, how long is it going to take to clear the COVID elective backlog? And the question is, can we use an open source solution to run this? So this is the model. So I will show you it in actual Stella first. So here it is. So it's a little bit more complicated. It's more like the ones that you've been seeing before. So we can run this. It works beautifully. We can fiddle with any of the variables. We can put the switches on, build a dashboard. Beautiful if you've got Stella. But if you don't have Stella, difficult to deploy because you either have to use Stella Simulator or a proprietary platform to get it out, or you have to code it bespoke, which will take a very long time and potentially have some issues, because in here you've got a conveyor and you've got various other elements which are often not supported by open source frameworks. So me and a chap called Wang Zhao from Strathclyde have been working on this, and we've been working on a framework which can cope with this, and we have now basically cracked this. It has been quite a lot of work, but we can share it with you. So this is the app here. Okay, so this is it's working in some form of production. So I can get that running. And then if you go in here and you go to run, you will find run is here. And you go here, this is where the source code is from. So you can do what you like with it. Okay, so this is more complicated. Let me just log into my other machine. I'm on one of the machines on a VPN, so it's the connection gets a little bit throttled. This model is, because it's heavier, it takes a little bit longer to load. And when you change it, the engine has to do quite a lot more work. So unlike in Stella where it's immediate, here there's we've still got some issues to solve in terms of caching and things like that. But it does work. And you can see it in the Streamlit in a second. And this, let me just go back to the presentation while that's loading. So I did have this all up, but then it decided to sort of stop working. So it doesn't work in these frameworks. So you can only use ASDM to compile it. And let's get that out. Don't fail me now. So one of the issues here is that Streamlit, the cloud deployment, may not have enough bandwidth to display it for everyone. So I suspect some people can see it, but it may not be. If everyone's hitting it at once, it's not used to having this much demand. So it may not be working, but you can always check it later on. But it basically allows you to adjust the time interval, adjust a couple of the stocks as per this. This is exactly the Blue Peter thing that I was trying to avoid. And what I can do, what I will do in time, is add in all the key auxiliaries into this dashboard, so that other people can just tinker with it and change different elements and make it run. And this is more like the kind of production-ready dashboard which a consultant would probably design in an NHS setting. So okay, I'll finish the talk and then we'll see if there are sort of questions at the end. So okay, so the future things we need to do. So we need to deploy more complex models using the open source solutions. So we've built a compiler. So we have a compiler which can compile from XML. But we need to make it faster because it's currently running in Python. So that's one of the things we're going to try to sort out. We need to add a GUI designer, which is a currently missing component from it. And we need to make it easier for people to modify and share those models. And as I've shown with Streamlit, it's not too difficult, but there's still barriers. And if people don't program in Python, they would probably find it quite difficult to do. And then what have we learned? So I guess we've talked about open source deployment. the disadvantages and advantages of open source and the potential future roadmap for doing this kind of work. So I'm going to stop sharing now, let Peter ask the question, and then if we've got time, we can go through one if you want.
Just going to make a point around that elective recovery model, which you and I have just shared over the last couple of days, which is if you've developed it in Stella, you've exported it, you've developed something, etc., then the key question then is how do you make it? The third point of the really useful models, or the second, I'm not sure, is how do you populate it? So if you download it and say this is a generic one that we can build, etc., what are the data requirements locally? So what's now Matt has now currently got from me is a sort of data spec, and there's as I think I mentioned this morning, there's a couple of different types of data. One is actual stuff that you can collect from your internal hospital systems, and that can be specified. And then there are a series of assumptions that are made in terms of how long do you think COVID recovery stuff will come back from, how much of it will come back, etc., which you can set as an initial set of approximately this, but that then gives you the tool to play with. So the next step in terms of making that model really useful is not only that you can get something that somebody else has thought of, you can take it and develop it yourself. You can also then populate it in a fairly standard way from internal data, and that gets over all the IG issues and everything else because you're doing it internal to the trust. I won't ask any technical questions.
There was a technical question in the chat box anyway. Mark, do you want to pick up that one?
Yes, and I was just going to add on what Peter just said there. That it has now loaded, and Peter's completely right. We need to get to a point where people can take it into their own environment and use it. That's why showing the source code is important, because it's here. So the source code's all here. So you can take the STMX file. You can take the development one. This is the STMX is there. We've got the ASDM one. The PISD doesn't work. So if you want to try and run it, it won't work. But the ASDM one does. And basically adapt it. So if you want to go into the model, so this is basically how you would do it in a hacky way, is you literally just go into the XMILE, you'd find the variables you want to change. So you just be like, I want to change this to 100, I want to change this to this, and it would just and then it would just display that locally. But we need to build a much better interface. That's not going to be something that will work sort of deploying it into trusts naively. Someone's got a specific question about the benefit of using Lambda to assign variables in the code. So let's go back to the code. So so I assume what they mean is in here. So basically, a Lambda function, just to explain what that is basically an inline function. So it's a function that you write that just like occurs in one line. So if you want to add a little element to a function, then you can. The different frameworks are designed in different ways. So PySD is very, very minimalist in terms of the commands that you use. So you basically call read XMILE, and then in this case model.run, then you can pass the parameters and it will just run them in. No, it's very, very lightweight. ASDM is in this case you can program it explicitly, or in the elective recovery model you can where the people may not quite sort of understand what's going on here, but basically you call structure on this and it builds the structure model from the XMILE file, so it compiles it. You could then add functions to that. Yes, you could, and we're going to try and improve it, make it better. Someone's asking about building a model to construct diagram, declarative modeling, building model use computer code. Potentially, yeah. So this is where it gets tricky, and you're right, it's kind of stalled. So like people have not been developing SD frameworks very much. So James Horton, who developed PySD, has pushed it forward to a point which is pretty good. There's not, and the documentation is very solid, but it's only useful for certain things. And what we need in the SD community is for these open source frameworks to become widely used, for people to widely share them, and just have that freedom to kind of develop on the back of it. Because until that happens, it won't become widely adopted. Someone's asked about the limitation to free Streamlit apps. Well, you've seen one of the limitations, which is about bandwidth and deployment. So this is running in the Streamlit cloud. It's completely free, but you don't have to use Streamlit. Streamlit is just a front-end display tool. It's quite nice. It uses React. It looks quite nice, but there are loads of other ways you can deploy it. Peter?
Are there any other technical questions before I make a non-technical point? I was just going to mention, you've heard Matt talk about Project Run and mention that we established it back in February. It's a not-for-profit. It's disruptive. It's sort of experimental. It's sort of get on board and see what we can do in this environment. So that's a real traction. It's not fully launched yet. We're working on website and Twitter handle, etc. So if you wanted to be sure to know when it happens and want to sort of get your hands dirty in that sort of open innovation space, then probably best is just to follow Matt or me on Twitter, and we'll be shouting about it when it gets going. So that's just a comment on something that's new to the field. Not completely. Other people have tried, but this is the latest attempt.
Does anyone else have any other questions? I'm aware that there's a lot of information here. It might look very daunting, very kind of difficult, and I didn't really want that, which is why I've tried to keep it as simple as possible. I don't know how much time we've got left, Vanessa. I presume about 10 minutes.
We got actually 5 minutes.
5 minutes,
yeah, but we are starting the other session at 22:04. So if we take one more questions and then we all move to the main room before
Douglas
we
has got.
yeah.
Douglas?
You may be muted. Let me check if I can unmute you. I'm afraid you need to unmute yourself. I cannot.
Sorry. Hello.
Yeah, we hear you now.
Right. Right. I put a number of questions in the chat. It's all very interesting and relevant and seems to be the direction that many things are going. What the issue that slightly concerns me is that I do think for the time being that if you actually want to learn system dynamics and if you want to learn how to build a system dynamic model, you really do need to use the proprietary software because in system dynamics, the diagram is the model and the model is the diagram. And if you want to audit somebody else's model or indeed audit your own model that you've returned to after some time, then you can do it quite straightforwardly in the diagram. To do it by auditing lines of code, I think it risks all kinds of error scraping. And so I think for the moment that open source is a wonderful way of sharing models that have been built using proprietary software. But for the many newcomers in this group, would you agree with me, as they say, that if you do want to get a grasp of system dynamics, for the moment, the message from this breakout is that we still need the proprietary software as things stand. That would be my contention, but I don't wish to disrupt the disruptors.
In some ways, I agree with you, Douglas, and I think that is a major problem with the currently available frameworks. And I think until we solve that, I think you're right. I think that it becomes very difficult. The problem is once you've developed a framework that works and it's very good, and it's very tempting then to commercialize that. This is what's happened previously, and that's what we need to be able to avoid, which is why we created Run fundamentally. No, because otherwise it's very easy to slip into that kind of mindset.
Liz,
I do agree with you. Yeah.
Thank you, Matt. We're going to take one last comment from Liz, and then we move back to the main room if everyone is okay with that. Thank you.
Oh, thank you, Vanessa. I'm just I hope I'm that Liz. Sorry. So I think, yes, I fully agree with the previous colleague. I think getting into the world of coding and using open source, it creates more confusion or in an already complex way of approaching system dynamics. I think proprietary rights perhaps is and it will be more amenable to our IT colleagues in the NHS to buy something rather than to use open source for the time being. The other thing is maybe this raises an interesting point for NHS England demand and capacity team. Maybe this is an opportunity where we could explore all of us together the possibility of developing some sort of software using open source or using any other method to accompany the modeling of system dynamics. So that is something that comes from inside the NHS, and it will be much more practicable in terms of its use. I think there is an opportunity there to complement the technical aspect of managing demand and capacity by looking at how we can build our own and then make it available across the NHS. It's only a suggestion. Thank you.
I think it's a great comment in there, Elizabeth, because that's why we have the next session actually, and it's how we all get together and start that community of practice. We are very aware of the software limitation. We believe Matt, Peter, and all people in Project Run, they are innovators here. They are going against the usual way of doing things, and we are very supportive of that approach. We are also aware of the limitations, and that's why we in NHS England, and in particular this team, we want to hear from people who have attended the event today, how you would like us to support you for the next financial year. So the next session, and we are going to move back to the main room, is back to you actually. What would you like to get from us? That's an option, but there are maybe many others that we could explore. Could be either investing in the open source software, something that we could scope, or can NHS England do something else? Thank you so much, Matt. You brought a very different perspective to what we were hearing during the day. Really valuable. Any final comment from you, Matt, before we go to the other room? We are already there. We should be there. I mean.
Yeah, no, it's nice to meet you all. Thanks, Vanessa. Thanks everyone for your questions. No, I think, yeah, we just need to build that sort of open environment, really.
Yeah.
Cool.
Thank you. See you in the main room. We post here the link if you need it. Otherwise, leave this room and resume the other one.